Hi everyone, thank you for joining me. Today we have approximately 3 objectives. Number 1, identify the path blood travels in the human circulatory system. Number 2, we are going to compare common illustrations that are used to demonstrate blood's path. We often see different ways that is represented. Some are more sophisticated than others. Oftentimes on high school exams it's overly simplified. We should really know the difference. And lastly, we're going to identify the consequence of a blocked artery. Alright, so let's start with some generic blood flow understandings. I'm going to start right here, a vein. All veins do lead to the heart. Arteries go away. That's a good thing to remember. Arteries away. From the bottom part of the body, it returns to the heart by what's called the inferior vena cava. Up here is the superior vena cava. Now this drawing is very crude, it's very basic. The reality is blood from the top part of your body is returning to the heart through this top branch. Now they enter the right atrium right here. Oxygen is low. The blood gave away its oxygen to the body parts. So right here in the right atrium, the heart squeezes, pushes the blood down into the right ventricle, where then that part of the heart squeezes, and again it's deoxygenated, low oxygen, so therefore high carbon dioxide. Blood is pushed through this valve right here into what's called the pulmonary artery. This vessel is going away from the heart. It's an artery. But the blood does not have oxygen yet. This is the only artery that carries deoxygenated blood. It then goes all the way up, actually more or less to the side. You'll see in the next picture where that is the reality. And it goes to the lungs where we do have gas exchange. The carbon dioxide diffuses out of the blood into the lungs for exhalation, and oxygen diffuses into the blood for being distributed to the body cells. Now, please do not get confused by these pictures. Blood is always red. Maybe a slightly different shade of red, but always red. Now, from the lungs, the blood goes back to the heart by way of the pulmonary vein, the only vein that carries oxygenated blood, so oxygen-rich blood. So now it is, and sorry my pointer is red, it's kind of blending in, so there's the pointer. So now the blood is in the left atrium, gets squeezed into the left ventricle, and then pushed into the aorta, the very first oxygen-rich artery that is now going to send the blood to the cells of your head, of your legs, of your arms, liver, kidney, even the cells that make up the heart muscle itself. Going to go through the aorta and then go through many different branches. Now down below here is where they're just suggesting that this is the entire body. So this represents the entire body, where the body cells are going to receive the oxygen by way of diffusion and give up the carbon dioxide that it produced in cellular respiration by diffusion, only to return back to the heart. Now in the next slide I'm going to show you a simpler picture that is sometimes used next to a more complicated picture that is sometimes used, and I'm going to use these dots to show you what they have in common. Okay, so here are these two illustrations. The one on the left is much more complicated than what you just saw. One on the right, much more simple. But different examinations are going to offer you illustrations in different ways, so let's get familiar with both. Let's start right here and right here and here. Okay, both of these locations are the veins. They're going to be bringing the blood back to the heart. So right here, superior vena cava, coming from your head. Down here, inferior vena cava, coming from the lower portions of your body, where on the right, it's showing the vena cava as both of them together. So blood will flow from the vena cava into the right atrium. Right atrium, we're in the same place in both illustrations. And my device for recording is sliding, forgive me. Alright, so here you're in the right atrium. Atrium squeeze, right atrium squeeze, blood goes into the right ventricle. Right ventricle squeezes, and the illustration on the left side shows the reality. Blood is going to go up through a trunk in the heart to the pulmonary arteries, and those are two. They're going to then split off to go to both lungs, the left and the right. Now on the right side, it's just showing one pulmonary artery going to lungs, much more simplified. And on the left now, the gas is now exchanged, carbon dioxide out, oxygen in. The blood is now oxygen rich, so it is oxygenated, and through the pulmonary veins are going to come back and meet up again in the left atrium. We're on the right, we're at the lungs, blood goes through the pulmonary veins, meets up in the left atrium. Now let's look at both pictures together simultaneously. The atrium squeeze pushes the blood down into the left ventricles. And here's where it changes once again. Picture on your left squeezes the blood up through a trunk into the aorta. The aorta is represented on the right diagram off to the side. That is not reality, but it simplifies things in this picture. And back, the blood then goes to the body cells. The right side simplifies it, brings it back to the body, but take a look at the left. Right at the aorta, there's a branch that goes up to the head, neck, and your left arm, in reality. And it also shows a branch going down to feed the lower portions of your body. And then it circulates back. You have to realize that these illustrations are truly the same thing. And now to what could be a great concern for many people, including myself. I do have heart disease in my family due to such issues as I'm about to show you. If you take a look at this top drawing, this is normal blood flow. Take a look at the opening inside of that artery. Think of it as a garden hose. Well, this garden hose, this time, starting to show some buildup of deposits right here. Notice how the opening is getting smaller. And then as time goes on, it gets even smaller. Now if that gets so cut off, or the buildup gets so large, the blood flow will get cut off, and anything that it is supplying might die. And if that happens to be your heart or your brain, your survival is going to be challenged. Take a look at this next slide, and I'll make it a little bit more real for you. So in this picture, it is showing the heart with major arteries that supply the heart with blood with high oxygen, and blood that will remove the carbon dioxide and toxins from the muscles because they are working, they're making toxins. In this picture, they are showing a branch of an artery right here that is being blocked, and here's a picture of it. This could be due to many things: poor diet, poor genetics. Unfortunately, in my case, both. So what we're talking about is high cholesterol potentially doing this. Now this would lead to what we call a myocardial, myo meaning muscle, cardio meaning the heart, infarction. That equals a heart attack. This is due to a blockage that does not allow blood to deliver oxygen to the heart muscle cells or remove the toxins. Please forgive the typo right here. So the question is, what do they do for this? Well, if they're lucky enough to find it, they can do something called angioplasty. My father had it done, and unfortunately it made the surgeons realize that they actually had to crack open his chest and do a full bypass operation. But they attempted this one first. This is called angioplasty, where you can see the blockage right here. And what they do is they insert this device actually through a vein in the leg, in the groin area. And it's a catheter. You can see the word right here. Let me increase the picture, move it up for you. And you'll notice that this device is going to expand. It's a balloon. It's called balloon angioplasty. And look at what it's doing to the opening. Let's go to the next section. And you will see that if this procedure is successful, the opening will be restored, blood flow will be restored, and someone has a very healthy life, and they are monitored regularly to see if there are any other issues that pop up in the future. To finalize and to complete this task, I want to show you a picture of what could happen, as stated earlier, if in fact there is a blockage of a blood vessel leading to the brain. If you notice here, it looks exactly like the picture that I showed you about a heart vessel being blocked, and you can see here in the picture of the brain, if the blockage is right here, the vessels that follow are not going to get their blood supply, and what's at risk? This portion of the brain, and you hope that is not a critical portion of the brain because it could have dire circumstances. Fortunately, if it is a non-critical part of the brain, you may not have any adverse effects whatsoever. And if it is a portion of the brain that does affect maybe speech or what have you, it's nice that we are resilient, and over time we could relearn some of the skills that we have lost. Thank you for watching.